Hi guys, I hope you are well. In today's session, we'll be looking at Poisson distributions, which is the second part of Learning Unit 2. And as you'll see, very similarly as we had done with the binomial distributions, I'll be taking you through the different ways that they can ask you questions based on a Poisson distribution. And then I'll also take you through the calculations of the mean and the standard deviation. So with your Poisson distribution, as you know, the formula that we follow is e to the power of minus a is multiplied by a to the power of x, and then this is over x factorial. So this is the formula we'll be using throughout. And again, just as we had with your binomial distribution, you're either required to have to do this calculation once, where they refer to one exact value for x. Alternatively, you might have questions where they say more than, less than, and so on, and you'll have to do this calculation more than one time and sum up your values. Alternatively, you might be requested or required to use the complementary rule. So we'll look at the different types of questions that can potentially be asked, and then we'll also, as I said, look at the calculation for your mean and your standard deviation. So without further ado, the question says that the telephone sales department of a certain store receives an average of 24 calls per hour. So your average, which is denoted by the symbol A in the formula above, is in this case 24. And please bear in mind that they have said to you that this is the average per hour. So in this formula of E is equal to minus A multiplied by A to the power of X over X factorial, E is automatically entered from your calculator. And then you have minus A, which is naturally going to come from whatever information they provided you with. They will tell you what the average value is. And then you're going to have the value of X exactly as it has been previously with the binomial distribution. It is the question from the question that you've been given. Determine the probability of, for example, 6, blah, blah, blah. So in that case, that would make the value of x equal to 6. And again, depending on the type of question that is being asked, you're going to find that you might have to substitute different values for x each time. So this is the value of x, and then in your denominator you also have x and you have the factorial sign, which is something that you would have come across in learning unit 1 as well. And your factorial sign you'll find is above the symbol x to the power of minus 1 on your calculator. So if you have a look at your calculator, towards the top portion where you have the on button, just below it to the left, you'll have a button which has x to the power of minus 1. Above that, you'll see the x factorial sign, and that is what you're actually looking for in this formula. The value of E you'll find is a bit lower than this. It is below this button on the right hand side, and it has Lin written on it, and just above this you'll see the E symbol. So this is where you'll find the values you'll need to enter for this formula. So that's on your calculators. And then, as I said, your X value is going to come from the question. Sometimes you might only be required to substitute for X once, where they refer to one specific value. Alternatively, you'll need to change the values of X according to how many different formulas you're required to determine. Okay, so we know the average is 24, so we know A is equal to 24. Again, the formula is e to the power of minus a multiplied by a to the power of x over x factorial. And then the first question says, what is the probability that there will be 18 calls in 1 hour. So again, please bear in mind that this average of 24 is per hour. So here they're saying determine the probability of x equal to 18. So in your formula, you're going to say, and please remember to always state this, that what you're calculating is the probability of x being equal to 18. So this then in the formula would be e to the power of a, which is minus 24 in this case. Remember, it's to the power of negative a. That's multiplied by a, which is 24, to the power of x, which is 18 in this case, and then over 18 factorial. So this would give you 0.0412. And again, if they ask you to leave this as a decimal, you'd leave it as is. Alternatively, if they require it as a percentage, you'll multiply that by 100, which would give you 4.12%. Okay, so I'll give you a second to take that down. Okay, so question B then says the probability that there will be that there will be 20 or 21 calls in 1 hour. This is saying to you that they want you to substitute the first time around for the value of x20, and then you're going to add to this whenever they say one or the other. It means you will be adding, so substituting then 21 in place of x. So you're going to substitute 20 and then 21 in place of x into the formula, and you're going to add up the values once you have done so. So when we substituted 20 in place of x in the formula, it would say e to the power of minus 24 times 24 to the power of 20 over 20 factorial. That would give you 0.0624. Then when you substitute 21 in place of x, that would be e to the power of minus 24 times 24 to the power of 21 is your x now, and then 21 factorial. So that would give you 0.0713. You're going to take this, add it to that, and then your final answer would be 0.1337. If they require it as a percentage, you'll multiply this by 100, which would be 13.37%. So if you recall, as I said to you when we had looked at the binomial distributions, if you are required to interpret these values, you would then just look at the question and sort of manipulate the words that go into it so that you can now have a closing statement. So the question for B asked, what is the probability that there will be 20 or 21 calls in 1 hour? So you would then state that there is a 13.37% probability or 13.37% chance that there will be 20 or 21 calls in 1 hour. So I'll give you a second to take that down as I now need to clear the screen. Okay, so question C then says the probability that there will be at least 3 calls in 1 hour. So saying that there would be at least 3 calls in 1 hour. This means that 3 is the minimum in this case, and it's everything above 3 and inclusive of the number 3 itself. So basically, they're saying here, determine the probability of x being at least 3, which means 3 and everything above it. So essentially, they're saying x being greater than and equal to the number 3. Now, in this case, as you know, with a Poisson distribution, we don't have a sample size. We don't know the value of n, which means that if we start with substituting everything after the number 3, that means we would substitute 4, 5, 6, 7, 8, and so on. And since we don't have a sample size, that means that we don't know what the end point would be. So with a Poisson distribution, there is no n value, which means that we would start off with the number 4 and we would continue into infinity, substituting for the value of x, which is naturally an infinite amount of calculations that we would need to do. And so when we have this type of question, we then use the complementary rule, which again says that the probability of A occurring is calculated by taking 1 and subtracting the opposite, which is the probability of A not occurring. So the exact same is going to be applied to this question, where now we're saying that the probability of X being greater than or equal to 3 is going to be 1 minus the probability of x being the opposite of that. And if we're saying here that x is greater than or equal to 3, then the opposite is less than 3, not inclusive of the number 3 because we have already included it here. So when we look at x being less than 3, we mean everything below the number 3, which is the number 2, the number 1, and the number 0. So now we're going to do 3 calculations, substituting 0 for x first, substituting 1 for x, and then substituting 2 for x. We'll add these up, and then we'll say 1 minus the probability of that. So I'll just write here the probability of x being equal to 0 plus the probability of x being equal to 1 plus the probability of x being equal to 2. And as I had pointed out, we would then sum those up at the end of it, and 1 minus that amount would give you your final answer. So here, x being less than or equal to 3, you're going to substitute. Remember, in the formula, e is to the power of minus 24. You'll multiply that by 24 to the power of 0 over 0 factorial. This would be e to the power of minus 24 multiplied by 24 to the power of 1 over 1 factorial. And then as you can see, each time only the x value is changing. And this would be x is equal to 2, so to the power of 2 over 2 factorial. So when you put this into your calculator, you're going to see a figure, like I had mentioned to you previously, that has, so it will give you 3.8, and then you'd have to the power of minus 11. What the minus 11 is saying to you is that there are 11 zeros before you enter the first digit here. So whenever you write this out, if you recall as well with the binomial distribution, I had said to you that it would always be 0 point, which is taking care of 1 0, but you need to have 11 zeros. So you're going to now enter the remaining 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you can write down the 3 and the 8. So 3, 8. Then for the next one, when you put it into your calculator, you'll have 9.1 and you'll have to the power of minus 10. Again, the minus 10 is saying to you that there would be 10 zeros before the first digit. So you'll always say 0 point, and then you'd need to enter, so this is 1 0, but you need 10 in total. So you're going to add on 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can enter the 9 and the 1 that you had here. The next one would have 8 zeros. So it would be 0.0000000. So in total, you would have 8 zeros, and then it would be 1, 1. So this would have been to the power of minus 8. So now that you have these obviously are extreme values. You might not come across such extreme values, and more often than not, you'll find that the values you'll have when you calculate these are not going to be as extreme as these where it's to the power of minus 10 or minus 11 and so on. Most of the time, the maximum number of zeros that you have to enter is about 3 or 4. This is an extreme example, but it is a good example because it helps you to understand the rule of to the power of whatever it is. And it again helps you to understand the complex examples that they give to you. Okay, so once you add these up, it gives you 0.000000012. So this would have been 8 zeros again. So 0.000000012, and then you'll say 1 minus that. So 1 minus 0. Okay, so 1 minus the figure that you had totaled, and so that gives you 0.9999, which again you can leave as that if they do ask you for decimals as your final answer. Alternatively, if they ask you for a percentage, you'd multiply this by 100, which would give you 99.99%. So this would be your final answer. And if you're asked to interpret, you'd say then that the probability that there would be at least 3 calls in 1 hour is 99.99%. Okay, so that is C. I'll give you a second to take that down. Okay, so let's continue with question D. So this says to you, what is the probability that there will be 9 calls in half an hour? So why I had stressed earlier that the average of 24 is per hour is in particular for this question where they're now asking you what is the probability that there would be 9 calls but in half an hour. So in this case, if the average was 24 and this was in 1 hour, it was per hour, for half an hour, our average is going to half. So it's half the time, and so it would be half of that average. And so instead of it being 24, it's now going to be half that, which is 12. So you're now going to have a new average in the formula, which is 12. So in this question, they were asking you the probability of x being equal to 9. And so it would be e to the power of minus 12 now, since a is now 12. 12 to the power of 9 over 9 factorial. And your final answer here would be 0.0874, which as a percentage would be 8.74%. So if they asked you to interpret, you'd say that there is an 8.74% probability that there would be 9 calls in half an hour. Okay, I'll give you a second. Okay, so let's have a look at then the additional calculations. In this case, they've asked you to calculate the mean and the standard deviation, which are very commonly asked questions when it comes to your binomial and Poisson distributions. For your Poisson distribution, to calculate the mean, it's actually already given to you, which is the value of A. So in this case, whenever it comes to a Poisson distribution, you don't actually have to work out anything for the mean. It will be given to you because your average, which is the mean, will be provided to you. So your average is 24. And then your standard deviation is calculated by the square root of your average. So the square root of 24 in this case, which is 4.90. Okay, so that's it for the Poisson distribution. And the next section we'll be looking at is the normal distribution questions, part of Learning Unit 2. And I will chat to you again soon. Thank you, guys. Cheers.